Morning students. Today we are going to learn the second chapter in the first unit, partial fractions. In this class we are going to learn the definition of a polynomial, definition of a rational fraction, and rules to find the rational fractions into a partial fractions problems. Polynomial. An expression of the form a0 into x to the power of n, a1 into x to the power of n minus 1 plus a2 into x to the power of n minus 2 plus dash dash an minus 1 into x plus an, a0 into x to the power of n plus a1 into x to the power of n minus 1 plus a2 into x to the power of n minus 2 plus dash dash an minus 1 into x plus an, where n is the positive integer and remaining coefficients a0, a1, a2, an are real numbers, is called a polynomial in x. It is called a polynomial in x and its degree is, here x power is n, degree is n if a0 equal to 0. If a0 not equal to 0. If a0 equal to 0, degree is n minus 1 like that. If a1 is not equal to 0. Its degree is n. If a0 is not equal to 0, it's a polynomial. Next. Examples of a polynomials. 2 plus 3x is the polynomial of degree 1. Because here x power, highest power of x is 1. So it is a polynomial of degree 1. And 2x to the power of 4 plus 4x square plus 20 is also polynomial. And highest power of x is 4. So it is a polynomial of degree 4. And x to the power of 4 plus 4x to the power of minus 2 plus 11 is not a polynomial because here x power is negative integer. A polynomial must contain a positive integer powers only. Okay. Next, rational fraction. Rational fraction, an expression of the form f of x by g of x, where f of x, g of x are the polynomials in x, and g of x is not equal to 0 is called a rational fraction. Means the rational expression, the expression f of x by g of x, where f of x, g of x are the polynomials in x. Means numerator and denominators are polynomial in x and denominator is not equal to 0, that is g of x is not equal to 0 is called a rational fraction. For example, x square plus 4 by x plus 3 and 2x plus 5 by x square plus 4x plus 1. It is the example, these are the examples of a rational fractions. And proper fraction. If degree of f of x is less than degree of g of x, then the rational fraction f of x by g of x is called proper fraction. Okay. Degree of f of x is less than degree of g of x. That means degree of numerator is less than degree of g of x. Then the fraction f of x by g of x is called a proper fraction. For example, x plus 4 by x square plus 2x plus 7. Here degree of numerator is 1, degree of denominator is 2. Therefore, it is a proper fraction. In second example, 9x minus 14 by x square minus 5x plus 7, numerator degree is 1, denominator degree is 2, numerator degree is less than degree of denominator, therefore it is also proper fraction, and etc. are the examples of a proper fraction. Next, improper fraction. Improper fraction means if degree of f of x is greater than or equal to degree of g of x, then the fraction f of x by g of x is called improper fraction. Means degree of numerator is greater than or equal to degree of denominator, then the fraction is called improper fraction. Example, x square plus 1 by x plus 1, x cube plus 3x plus 4 by x square plus 2x plus 3 dash dash are the examples of improper fraction, because numerator degree here first example 2 and denominator degree 1, means it is improper. Degree here 3, numerator, denominator is 1, 2. Therefore 3 is greater than 2, therefore they are the improper fractions. Next, partial fractions. Resolving a given fraction into a partial fractions. Resolving a given fraction into a partial fractions is nothing but expressing it as the sum of two or more simpler fractions. Expressing the fraction as sum of two or more simpler fraction. Fraction means numerator by denominator. If this fraction can be expressed as it as sum of two or more simpler fractions, that process is called resolving a given fraction into partial fractions. Okay. There are several methods are there. We will see in the next slides several methods. Rules to find resolve a proper fraction f of x by g of x into a partial fractions. We have total 4 rules to resolving a given proper fraction into a partial fractions. Resolving a proper fraction into partial fraction is nothing but the fraction is converted into sum of two or more simpler fractions. In this first case, we have total 4 methods. In that first method, if g of x means denominator in the fraction g of x contains non-repeated linear factors, that is f of x by x plus a, x plus b. In the denominator, we have x plus a, x plus b. They are 2 factors with x degree is 1. Means they are linear factors. Then it can be expressed as a by x plus a plus capital B by x plus b, where capital A comma capital B are constants. We have to find out. How we find means it will be, I will explain in the problems. Okay. Next is third class. If it is a 3 factors in the denominator f of x by x plus a into x plus b into x plus c, 3 linear factors, non-repeated linear factors, then it can be expressed as a by x plus a plus b by x plus b plus c by x plus c. For each linear factor, one constant, and we have to calculate capital A comma capital B comma capital C in the problems. I will explain in the problems how to calculate. This is the first case. G of x contains non-repeated linear factors. Next, second case, if g of x contains repeated linear factors, then that is f of x by x plus a whole square equal to a by x plus a plus b by x plus a whole square. X plus a is a linear factor. It is coming 2 times. Repeating. Whole square means repeating. That can be expressed as a by x plus a plus b by x plus a whole square. If it is a whole cube, then we get another fraction c by x plus a whole cube. Like that we have to go on. Next, for example, f of x by x plus a, x plus b whole square. One linear factor, another is a repeated linear factor. Both are linear factors only. One is the non-repeated, another is repeated. For non-repeated, one constant, one fraction a by x plus a, and repeated linear factor b by x plus b plus c by x plus b whole square. That is the second case. Repeated linear factors. Next, third one. If g of x contains non-repeated quadratic factors, that is f of x by x plus a into ax square plus bx plus c. Here denominator contains quadratic factor ax square plus bx plus c, and one is the, here I am taking one linear factor. This can be expressed as a by x plus a. For linear factor, a by x plus a. For quadratic factor, we write bx plus c. Bx plus c by ax square plus bx plus c. Okay, for linear quadratic factor, we can write in the numerator bx plus c. For linear factor, we write only constant a. And next, fourth case, if g of x contains repeated quadratic factors, then that is f of x by ax square plus bx plus c whole square. It is a quadratic factor and 2 times repeating. that is can be expressed as ax plus b by ax square plus bx plus c and c plus cx plus d by ax square plus bx plus c whole square. Okay, these are the four cases, four possibilities. First one, g of x contains non-repeated linear factors. Second one, g of x contains repeated linear factors. Third one, g of x contains non-repeated quadratic factors. And fourth one, g of x contains repeated quadratic factors. Based on this, we will do the problems. First problem. Okay. Resolve the following fractions into partial fractions. First one, 1 by x plus 2 into x plus 3. Okay, 1 by x plus 2 into x plus 3. Here denominator contains two factors, x plus 2 and x plus 3, and powers are 1, so they are linear factors and they are different, they are not repeating, therefore it is a non-repeating linear factors. So first case, so we get 1 by x plus 2 into x plus 3 equal to a by x plus 2 plus b by x plus 3, means it can be expressed as a. We have to identify b, we have to calculate a value, b value in the expression. We will see how to calculate. LHS is same, 1 by x plus 2 into x plus 3. Here in the RHS denominator, LCM is x plus 2 into x plus 3. So if you divide with x plus 2 and x plus 3 is the LCM, x plus 3 is the LCM. By if we divide with x plus 2, x plus 2 cancel, x plus 3 is remaining. So a into x plus 3. If we divide with x plus 3 cancel, we will have x plus 2. So b into x plus 2. Okay. That is 1 by x plus 2 into x plus 3 equal to a by x plus 3 plus b into x plus 2 by x plus 2 into x plus 3. In RHS denominator, LHS denominator cancel. Then we get 1 equal to a into x plus 3 plus b into x plus 2. That is equation 2. And that is 1 equal to a into x plus 3 plus b into x plus 2. So to get a value, this b term must be 0. That is, we have b coefficient x plus 2. So x plus 2 equal to 0. That is x equal to minus 2. So substitute x equal to minus 2 in the equation 2. We get 1 equal to a into minus 2 plus 3 plus b into minus 2 plus 2. Minus 2 plus 2 means it is total 0. 0 into b 0. That is 1 equal to minus 2 plus 3 means 1. A into 1 means a. Therefore, a equal to what? 1. Next, to get b value, a term must be 0. That is x plus 3 equal to 0. Coefficient must be 0. That is x equal to minus 3. So, substitute x equal to minus 3 in the equation 2. 1 equal to a into minus 3 plus 3 0. So, a into 0. So, b into minus 3 plus 2. A into 0 means this term total 0. So 1 equal to minus 3 plus 2 means minus b. Therefore b equal to minus 1. A equal to 1 value, b equal to minus 1 value. Substitute in the equation 1. We get, what is the equation 1? A by x plus 2 plus b by x plus 3. A equal to 1 and b equal to minus 1. If you substitute in the equation, that is 1 by x plus 2 into x plus 3 equal to 1 by x plus 2 minus 1 by x plus 3 is the answer. Okay, we are simplifying once again. I am simplifying LCM. I am taking LCM. First of all, it is a non-repeated linear factors. So I am writing expressing as a by x plus 2 plus b by x plus 3. Then taking LCM and denominator cancel out, we get this expression. To get a value, b term must be 0. To get b value, a term must be 0. That is x equal to minus 2, x equal to minus 3. Like that we will get answer. Okay. Next problem, 3x by x minus 2 into x plus 1. Here also denominator contains, we will see only denominator. Here also denominator contains non-repeated linear factors. Both the factors x minus 2 and x plus 1 are the linear factors and they are not repeating, not equal. Therefore, it can be written as, in the first case, 3x by x minus 2 into x plus 1 equal to a by x minus 2 plus b by x plus 1. So LCM x minus 2 into x plus 1 and we get x minus 2 cancel, a into x plus 1, x plus 1 cancel, b into x minus 2 and denominator in both sides cancel out and we get 3x equal to a into x plus 1 plus b into x minus 2. Next problem. So to get a value, b must be 0, that is b coefficient is x minus 2. So we have to substitute 0 means x equal to 2 in the equation 2. Put x equal to 2 in equation 2. 3 into 2 we get 6. A into 2 plus 1 3, that is 3a. Okay, b into 2 minus 2, that is 0. So 6 equal to 3a. A equal to 6 by 3, that is a equal to 2. Next, to get b value, a must be 0, a coefficient is x plus 1 means x equal to minus 1. So substitute x equal to minus 1 in the equation 2. We get 3 into minus 1 plus a into minus 1 plus 1 plus b into minus 1 minus 2. Wherever x we have to substitute minus 1. So minus 3 into 1 minus 3, a into minus 1 plus 1 means 0, a into 0 plus b into minus 1 minus 2 means minus 3. So a into 0 is this term total 0, minus 3b equal to 3 into b minus 3b equal to minus 3. So b equal to minus 3 by 3, that is 1. Minus minus plus 3 cancel out, we get 1. So a equal to 2 and b equal to 1. So substitute this a value, b value in the equation 1. A by x minus 2, b by x plus 1. A means 2 here. Okay, a means 2, 2 by x plus x minus 2, 1 by x plus 1. Okay, 2 by x minus 2 plus 1 by x plus 1 is the answer. Let us go for the next problem. Here printing mistake, it is 2 by x minus 2, 1 by x plus 1. Next problem, 2x plus 1 by x minus 1 into x plus 3. Here also denominator contains non-repeated linear factors. X minus 1 is the linear factor, x plus 3 is the linear factor. They are not repeating, not coming twice or thrice. So using first case, 2x plus 1 by x minus 1 into x plus 3 equal to a by x minus 1 plus b by x plus 3. By taking LCM on RHS side, LHS is same, 2x plus 1 by x minus 1 into x plus 3. RHS, x minus 1 into x plus 3 is the LCM. We get a into x plus 3 plus b into x minus 1. Denominator is cancelled out. We get 2x plus 1 equal to a into x plus 3 plus b into x minus 1. To get a value, b term must be 0, means we need to substitute x equal to here x minus 1. So x minus 1 must be 0, that is x equal to 1. Put x equal to 1 in the equation 2. So 2 into 1 plus 1 plus a into 1 plus 3 plus b into 1 minus 1. 2 plus 1, 1 plus 3, 4, 4a, b into 0. b into 0, 0 means total 0. 4a equal to 3 equal to 4a, a equal to 3 by 4. Is the a value. Next, to get b value, a term must be 0, that is x plus 3 coefficient, x plus 3 equal to 0 means x equal to minus 3 in the equation 2. So substitute x equal to minus 3 in the equation 2, we get 2 into minus 3 plus 1 plus a into minus 3 plus 3 plus b into minus 3 minus 1. If you simplify, that is minus 6, 2 into minus 3, minus 6 plus 1 plus a into 0 plus b into minus 3 minus 1 means minus 4. This term is 0. Minus 6 plus 1 equal to minus 5 minus 4b minus minus plus and b equal to 5 by 4. So a equal to 3 by 4, b equal to 5 by 4. Substitute in the equation 1, a by x minus 1, b by x plus 3. We get answer is from equation 1, 2x plus 1 by x minus 1 into x plus 3 equal to a value 3 by 4. So 3 by 4 into x minus 1, b value is 5 by 4. So 5 by 4 by x plus 3. After simplification, 4 will come in the denominator. 3 by 4 into x minus 1 plus 5 by 4 into x plus 3 is the answer. Let us move for the next problem. 2x minus 1 by x minus 1 into 2x plus 3. 2x minus 1 by x minus 1 into 2x plus 3. Here also denominator contains two linear factors, non-repeated linear factors only, x powers 1. Then by first case, it can be expressed as 2x minus 1 by x minus 1 into 2x plus 3 equal to a by x minus 1 plus b by 2x plus 3. And taking LCM in RHS, LHS is same. RHS x minus 1 into 2x plus 3 is the LCM. If you divide with this LCM with x minus 1, we get 2x plus 3 and x minus 1 into 2x minus 3. If you divide this one by x minus 1, denominator of a, x minus 1 cancel, we will remaining with 2x minus 1, 3, 2x minus 3 into its numerator, a into 2x plus 3. 2x plus 3. Next, if we divide with this x minus 1 into 2x plus 3 is divided with 2x plus 3, 2x plus 3, 2x plus 3 cancel, x minus 1 into its numerator b into x minus 1. Okay, that is a into 2x plus 3 plus b into x minus 1 by x minus 1 by 2x plus 3. Then denominator both sides cancel. 2x minus 1 equal to a into 2x plus 3 plus b into x minus 1. Next, to get a value, b term must be 0. B term means x minus 1 is there. So put x equal to 1 in the equation 2. 2 into 1 minus 1, that is 1. And a into 2 into 1 plus 3, that is 5a. 2 into 1, 2, 2 plus 3, 5. b into 1 minus 1 means 0. Therefore, 1 equal to a into 5. So, a equal to 1 by 5. It will divide. A value is 1 by 5. Next, to get b value, a term must be 0, means 2x plus 3 must be 0. 2x plus 3 is 0 means 2x plus 3 equal to 0. So, 2x equal to minus 3. So, x equal to minus 3 by 2. Okay. We have to substitute x equal to minus 3 by 2 in the equation 2. That is, put x equal to minus 3 by 2. 2 into minus 3 by 2 minus 1. So, a into 2 into minus 3 by 2 plus 3 plus b into minus 3 by 2 minus 1. Here 2 cancel, minus 3 minus 1. Here 2 cancel. Minus 3 plus 3 0, so a into 0. So b into 2 is the LCM, minus 3 minus 2 by 2. Minus 1, 3 minus 1 means minus 4 and a is 0, the term is 0. Minus 5 by 2 into b. Minus plus 2, this 2 will comes into LHS, 4 into 2 8, 8 equal to 5b. So b equal to 8 by 5. So substitute this b value and a value, a equal to what? 1 by 5, b equal to 8 by 5. In the equation 1, we get the answer is 2x minus 1 by x minus 1 into 2x plus 3 equal to 1 by 5 into x minus 1 plus 8 by 5 into x plus 3. After simplification, 5 comes denominator, here also 5 comes in the denominator, that is answer 1 by 5 into x minus 1 plus 8 by 5 2x plus 3 is the answer. Let us move for the next problem. X plus 1 by x square plus 5x plus 6, x plus 1 by x square plus 5x plus 6. If you look at this, denominator contains quadratic factor. We think that it is a quadratic factor. But before deciding it is a quadratic factor, we have to factorize. If factors are not coming, then it is a quadratic factor. Take it as a quadratic factor. But here, if you factorize it, x square plus 5x plus 6 can be factored as x square plus 2x plus 3x plus 6. 5 can be written as 2 into 2x plus 3x. 2 into 3 means we get 6. 6 can be written as 2 into 3. How to factor it? 6. This 6 can be written as 2 into 3. 5x can be written as 2x plus 3x. We have to express that. And that is x square plus 5x plus 6 can be written as x square plus 2x plus 3x plus 6. In the first two terms, x is common, x plus 2. Next two terms, 3 is common, 3 into x plus 2. In the both the terms, x plus 2 is common, again x plus we get x plus 3 is the answer. Means x square plus 5x plus can be written as 6 can be written as x plus 2 into x plus 3. Means they are linear factors. X plus 1 by x square plus 5x plus 6 can be written as x plus 1 by x plus 2 into x plus 3. Then here also denominator. Now the factors are linear factors. Don't take directly. We have to factorize it. If factors are not coming, then take it as a quadratic factor. Here factors are coming, that are x plus 2 and x plus 3. Two linear factors and non-repeated linear factors. So first case, a into x plus 2 plus b into x plus 3. And simplify and find out a value, b value. So LCM, x plus 2 into x plus 3, the LCM, we get a into x plus 3 plus b into x plus 2. Denominator cancel both sides. So x plus 1 equal to a into x plus 3 plus b into x plus 2. So to get b value, a value, b term must be 0, that is x equal to minus 2. To get a value, to get b value, a must be 0, that is x equal to minus 3. X equal to minus 2, we get a value. X equal to minus 3, we get b value. Let us see. X plus 1 equal to, we have x plus 1 equal to a into x plus 3 plus b into x plus 2. To get a value, b must be 0, b term, x equal to minus 2. So put x equal to minus 2 in the equation 2. We get minus 2 plus 1 equal to a into minus 2 plus 3 plus b into minus 2 plus 2, 0. Means this term is total 0. So minus 2 plus 1 means minus 1. A into minus 2 plus 3 means 1. So a into 1 a. Therefore a equal to minus 1. Next, to get b value, a term must be 0. That is x equal to minus 3 in the equation 2. So minus 3 plus 1. Minus 3 plus 1. So a into minus 3 plus 3, 0. B into minus 3 plus 2. Minus 3 plus 1 means minus 2. This term is 0. B into minus 3, 2 means minus 1. Minus minus plus b equal to 2. A equal to minus 1. B equal to 2. So substitute in the equation. X plus 1 by x square plus 5x plus 6 equal to minus 1 by x plus 2 into 2 by x plus 3. Minus 1 by x plus 2 plus 2 by x plus 3 is the answer. Next, let us move for the next problem. Means in this problem, it is directly not factorized. So we have to first try for the factors. If you get factors, then it is a linear factor. Otherwise, it is considered as a quadratic factor. Second case. Next one. 1 by x into x minus 3. Here also both x and x minus 3 are linear factors. So substitute in the first method only, it is linear factors, non-repeated. Therefore a by x plus b by x minus 3. So LCM simplification, x into x minus 3 is the LCM. So we get x cancel, a into x minus 3 cancel, b into x. Denominator both sides cancel, 1 equal to a into x minus 3 plus b into x. To get a value, b must be 0, bx means only here x is there, so put x equal to 0, that is in equation 2, 1 equal to a into 0 minus 3 plus b into 0. b into 0 means this term is total 0, a into 0 minus 3 means minus 3a, so a equal to minus 1 by 3. Okay, 1 equal to minus 3a, so a equal to minus 1 by 3. And to get b value, a term must be 0, means x minus 3 equal to 0, means x equal to 3. We have to substitute x equal to 3. Put x equal to 3 in the equation 2, 1 equal to a into 3 minus 3, 0, so b into 3. So 3b equal to 1, so b equal to what? 1 by 3. So substitute this a value, b value in the equation 1. A equal to minus 1 by 3, b equal to 1 by 3 in the equation 1. So we get 1 by x into x minus 3 equal to minus 1 by 3 into 1 by 3 by x plus 1 by 3 into 1 by 3 by x minus 3. 3 comes to denominator, minus 1 by 3x plus 1 by 3 into x minus 3 the answer. Okay. Up to now we discussed the 4 methods, 4 problems, but the problems only on the first case. First method problems only, non-repeated linear factors. Next, homework problems. Resolve the following partial fractions into partial fractions. Following fractions into partial fractions. First one, x minus 4 by x square minus 5x plus 6. Second one, 1 by x minus 1 into x plus 2. And third one, 2x plus 3 by x square minus 2x minus 3. And fourth one, 7x minus 1 by 3x minus 1 into 2x minus 1. And fifth one, 1 by x minus 8 into x minus 11. In the problems, second problem, fourth problem and fifth problem, already they are factorized, their factors are there. But in the third problem and first problem, we have to, first of all, we have to factorize. In the first problem and third problem, denominator is quadratic, so we have to factorize. First we have to factorize the denominator, then proceed. Okay, in the first problem, x square minus 5x plus 6 can be written as x minus 2 into x minus 3. And in the third problem, x minus 3 into x plus 1. Okay, then factorize, it will comes in the first case. And answers are given here. You have to check it out with the answer. Okay. Thank you. In this class, I will repeat, in this class we discussed about the definition of a partial fraction, polynomial, first of all polynomial, and next the rational fraction, proper fraction, improper fraction, and rules to convert the proper fraction into partial fractions, and problems on first case. We discussed about 4 cases, in that we discussed about problems on first case. Okay, thank you. We will discuss remaining methods problems in the next class. Okay, thank you very much.